Today we are solving linear equations. Linear equations are equations that have plain ordinary x, and they typically have just one solution. This is the first slide that you have in your notes packet. We want to review how to solve this linear equation. So 3x minus 15 equals 0. What would you do first? Add 15 to both sides. That would give us 3x equals 15. And then we would divide by 3 to get x equals 5. In example B, what would you do first? Subtract 3. Okay, this is x divided by 3, so to undo it, we would multiply by 3. So we end up with x equals -9. Okay, on the next slide, what do you think we should do first? Combine like terms. 3y and -5y is -2y plus 8 equals 4. Subtract 8 on both sides. Divide both sides by -2. What do you think you need to do in this? Honestly should say example 2b. I don't know why it says another a. We would need to distribute. So take a moment, distribute. Don't forget to distribute the -3 to the x and to the -2. Take a moment and solve that one out. Okay, you do have multiple options. You could subtract 2x on both sides. You could add 3x on both sides. I like to keep things positive whenever possible. Some people also will try to subtract 4 at the same time that they're adding 3x. If you are able to do multiple steps at once and still keep track of what you're doing, great, go for it. Personally, it usually confuses me and ends up making me do something wrong. So I usually don't do multiple steps at once if I can help it. We would divide both sides by 5. Don't worry about getting out a calculator. The answer is 2/5. If you do get out a calculator and you change that into a decimal, that would be 0.4. All right, on the next slide. When I first looked at this, I thought, oh, we don't need to do these, but we kind of do. If we start by distributing, we have 2x plus 3 equals 2x plus 8. What would you do next? Subtract 2x. Some of you already figured out what's going on here. When we subtracted 2x, it made the variables cancel on both sides of the equation. And what we're left with is 3 equals 8. Does 3 actually equal 8? No, this is a false statement. If your variables all cancel and you're left with a false statement, your answer is no solutions. Anything that we would plug into that equation would not work. It doesn't matter what x value you pick, nothing would work. There are no solutions that exist that would work for that equation. When we distribute in B, we end up with 4x plus 12 equals 4x plus 12. Do you notice anything fishy about this one? They're exactly the same. And if we take the time, maybe we don't notice that they're exactly the same. We would end up with 12 equals 12. 12 definitely does equal 12. That is completely true. So this one would be all real numbers. If you're left with a true statement, the answer is all real numbers. If you're left with a false statement, it's no solutions. So we could pick any x value in the world and plug it into that equation, and it would work. It would create a true statement every single time. All right, we love word problems, so let's do a word problem. You have 96 feet of fencing to enclose a rectangular pen for your dog. To provide sufficient running space for the dog to exercise, the pen is to be 3 times as long as it is wide. Find the dimensions of the pen. All right, so we've got a rectangle. And I'm going to call this dimension W. I'll call that the width, W. What do you know about the length compared to the width? 3 times as long, so 3W. We have 96 feet of fencing. Fencing typically goes along the outside of the enclosure, and enclosed, that's another word for around the outside. So we need to find the perimeter. They're asking us to use the perimeter. So we've got W, 3W, another W, another 3W. So W, 3W, W over here, and 3W up here. That has to add up to 96 feet. How many W's do we have? 8 W's. And 96 divided by 8? 12. Okay, look at the last sentence of the word problem that I highlighted in pink. Does it ask for what W is? It asks for the dimensions of the pen. So the dimensions of the pen are 12 feet by, what's 3 times 12? 36 feet. Our dog will have a 12-foot by 36-foot enclosure. Tickets for a concert cost $175 for each floor seat and $95 for each stadium seat. There were 2,500 seats on the main floor, and these were sold out. The total revenue from the ticket sales was $865,000. How many stadium seats were sold? So, 1 floor seat is $175. How much is 2 floor seats? 2 times 175. If you want 5 floor seats, it's 5 times 175. If you take $175 times the number of floor seats, that will give you the amount of money for floor seats. Similarly, if we take $95 per seat and multiply it by the number of seats, I'm going to use X instead of S so it doesn't look like a 5. This will give us the amount of money for stadium seats. If I add those two amounts together, it should equal the total amount that we collected from ticket sales. Normally, this would be a systems of equations problem, but they gave us some extra information. They gave us this information. There were 2,500 floor seats, and they were all sold out. So we know that F is 2,500. We don't know what X is. X is what we are trying to figure out. So take a moment and finish solving that. Figure out what X is. After you solve it, you should end up with 4,500. Make sure you go back to the last sentence In English, the first sentence is the most important. In math, the last sentence is the most important. So, how many stadium seats were sold? 4,500 stadium seats. Make sure your answer truly answers the question with a label. Your assignment is on page 103. Note that your notes packet covers 3.1 to 3.4. The assignment sheet that I'm going to give you is all of chapter 3.